you still want to think of this as like separate triangles, because you have a right triangle here, and you're always going to assume in a real world situation when they give you a picture like the one in the book, it tells you in the book for problem 7, each figure shows a pair of similar triangles. So right away, you know that you have similar triangles from the reading. And so you've got the big triangle, and then you have the triangle within the triangle, the red one. So you have got this picture here, and this one here. And so then you want to transfer your values. This is 10 and 14. But this whole distance is 38 and h. So your ratio is going to be h compared to 38 as 10 compares to 14. Does that make sense? So h over 38 is one way to do it, as 10 is to 14. Okay, so from now on, we probably need to, no matter how I write a ratio down, you should know by now there's 3 other ways to write it, right? So chances are I'm not going to always set it up the way you set it up, but you have to start getting comfortable with the fact that there's 3 ways to write it. So if I do it one way and you do it a different way, as long as our cross products remain the same, meaning that I have 14h and 38 times 10, you don't need to keep asking if you could set it up a different way, because you want to be comfortable with the first step could be set up 4 different ways, but as long as our second step matches, we're good. Okay, does that make sense? Now, on the video that I posted yesterday, really encourage you not to multiply the 38 times 10 out, because it helps when you do division to reduce along the way, and it simplifies your work. So for example, 2 goes into 14 7 times, and it goes into 38 19 times. Right? Now here's the thing, if 7 has nothing in common with 19 or 10, then there's no more reducing to be done. 2 goes into both of them.
Okay.
Right?
Yeah.
Otherwise I would have had a 1 here. Right? So we're just practicing some of these skills. So this is 190 over 7. And then now let's practice the short division. So 7 goes into 19 how many times? 2. So 2 times 7 is 14. What's your remainder? 5. 7 goes into 50 how many times? 7, right? And your remainder, so put a decimal is 1, right? So 7 goes into 10 once, right?
Remainder
3. And was there rounding directions? So if it says round to the tenths, you need to go to the hundredths and see what you have to decide how to round. 7 goes into 34, so that tells us we're going to round to 27.1, and our units were feet. Olivia?
So you said not to multiply 38 times 10, but it confuses me not to do it.
Okay, but I'm telling you that when you have a no calculator test, which is what you're going to have, and your numbers get really big, if you practice this, you're not going to run out of time. A lot of people are getting to these big numbers. For example, if you look at the example from last night that I did here, even if you didn't look at the video, this situation over here becomes very big. 8 times 225, and then you have to divide, so you're wasting time. So I would practice it.
So it would be wrong?
It's not going to be wrong, no, but if you ask for extra time, the answer might be no, right? Because your calculator, non-calculator skills are one of the things I'm testing you on. You have to start showing that you can function without a calculator. Some of you have gotten really dependent on that, or it's taking you a really long time to do what we would consider kind of basic math. So I'm suggesting, since you don't have a calculator, that you practice your reducing, because that will help you. Okay, so number
11.
well, we'll start with one and go to the other. Well, 7 came up, and then after I started to write it down, somebody asked for 3, right? So I'm going to go on to 9, and then we'll go back to 3, because we have a picture of 3 on a different page. So number 9. Is the Washington Monument problem. So you have basically you have a tall, do you know what the shape of the Washington Monument? Yeah, it's called an obelisk, right? So that's kind of an interesting shape. So we're going to just say that it casts a shadow that's 200 meters long. So imagine anytime you hear that, you know that you're sort of setting up a right triangle situation. So this is your shadow, and this is your Washington Monument, and we don't know what the height is. Okay, but we are going to create this triangle here. And this picture is a little bit different. It says at the same time, a nearby van. So it doesn't have to be a triangle within a triangle. You could just have a triangle at the same time of day with the sun being at the same angle would create. Well, it says at the same time. So actually, think about that. What you're saying, not really, because every single day, assuming you don't grow a lot, at like 2 o'clock, your shadow should be the same length because of the position of where the sun is. And think about as the day goes on, your shadow gets longer. Do you know what I'm saying? So if you're standing in your backyard, your shadow is going to be the same length today at 4 o'clock as it was yesterday at 4 o'clock. And so if you're standing next to a tree in your backyard, the relative length of the tree shadow is going to change the same way your shadow would change as the day goes on. So that's why it creates similar triangles. Does that make sense? Because the position of the sun relative to the two objects is the same. So it doesn't say that, but we didn't talk about that particular situation, but if you look at the examples, I think they talk about one of those situations. And if they didn't, we'll talk about it now. We just didn't get to every situation. So the van's 2.1 meters high, and it casts a shadow that's 2.5 meters long. So we're just going to compare x to 200 as 2.1 compares to 2.5. So here's a couple of things that could help you without a calculator. But before I do that, does the setup make sense? A lot of people don't like the decimals, so this is the same as 21 over 25. Because you can multiply the top and bottom by 10, right? And that sometimes helps people when you don't have a calculator. Does that make sense? So, let's bring that over there where it's not crowded. Cal.
Well, since it says like at the same time, could you still draw this one?
You could. You could draw out a triangle within a triangle, even though we don't really know that. It's not going to affect the math. Naive?
It says that the Washington Monument is 168.
Yes.
Can you let
Did you look it up? Really? Oh, Naive, that's awesome. I didn't know that. Well, I think you should write the publisher and tell them they made a mistake.
Well, maybe it's supposed to be made, but
Maybe it's because it was a.
Wait, so what is
Never know. If we did because I just set up a portion right off of that, like I did it never know.
Okay, good question. A couple good questions. Interesting fact, though, Naive.
Can we do it?
Oh.
But they should. The monument didn't change height, so, maybe they wanted you to have even numbers or something. I don't know. Maybe they just had their source wrong. Maybe your source isn't wrong, right? I don't know. So, where'd you look it up? Google? Probably it's right. Did you look more than one source up? Yeah? Huh. Well, you did better than I did. I didn't look at it. The question that Zig asked also is important. On the test, I'm going to expect that you can draw me a picture. If I say draw a picture or show the similar triangles, then I would expect to see it. If I don't, you could just jump to what's here in blue. Oops. Matthew, question?
Oh, never mind. I just realized answer.
So we're going to cross multiply here. So we get 200 times 21. And I bet this is why I think they probably fudged it a little because they wanted the numbers to work out nicely. Or maybe they rounded these numbers a bit. And so it just caused that little bit of an error. So here's my point. Like, those of you guys that are reluctant to do what I'm asking are going to have a lot more stress on your test because you don't want to reduce.
Isn't that 2,000?
200 meters?
But you moved the decimal place.
No, I moved the decimal place here.
Oh.
So if you practice reducing, yeah, so much easier, right? 8 times 21 is way easier than doing 200 times 21 divided by 25. One other question, Natalie? Okay, so going back to earlier, the first thing I did was I said if you don't like working with decimals, multiply the numerator and denominator by 10, right? And then you have 21 over 25. The value is exactly the same, but your stress level is better. So 8 times 21, what's 8 times 20? 160, and what's 8 times 1? So 168. That's way quicker. So I really, and part of what I'm testing is no calculator work. How is your skill work without a calculator? Green.
When you reduce, do you just have to reduce one number on top?
You can only reduce.
You
can't like divide 25 into both.
Can you do divide by 25, but then if it's like a 2 or a 7, can you divide again with the other one?
Well, we've been doing that too, right? Just not on this particular problem, but you can continue to reduce. Is that what you're? So let's look back here at we'll just do another problem when we get to this one, and we'll look at that as an option. Olivia.
So if you were reducing, what if the number on the bottom could go into both the numbers that you're multiplying on the top?
You can only
Do you pick which one?
pick one.
Bigger.
Matthew.
Well, it's just something that I is in Greek mythology about obelisks and shadows. It said that the first creation was an obelisk, and the shadow of it was also the shadow of Apophis, the god of chaos.
Really?
Yeah.
See, I'm learning so much today. Okay, let's go to problem 3, this picture, right? No, I have a worksheet for you. The smart board's kind of freaking out here, but I would, but we'll run out of time, so I'm not going to. Okay, so let's look at problem 3. It has to do with this picture, right? Is that correct? So, can you guys see that better back there? It's number 3. It says find the distance across the lake. D. So I did this one, I think last night, but here's the important thing. T and P have to be the same. So my suggestion is redraw this picture so you don't mix things up. If this is your P value right here, and this is your triangle, take it out and rotate it. So, I know,
A little easier.
but you could do it, and then you have your letters in the right places, you know what I mean? So like P and T are on the bottom right, Q and S line up, and they're on the bottom left. And then it's easy to transfer your numbers, because this is D, and from R to Q is 225. And so now we're going to compare 225 to D as 150 compares to 240. Okay, so when I do that, hang on, Cal, let me just set this up and then I'll do your
It
question.
would always be the bigger number on the bottom. And then
No, again, there's 4 ways to set up the ratio, right? So there's not an always. And also, you really, what it comes to is how these letters are arranged. So you have to make sure if P is on the, P has to be in the same relative position as T, meaning they're both on the bottom right. And then the Q and the S have to be in the same relative position. So then, but there's no always to most of these. You have to be flexible. So 225 compares to D as 150 compares to 240. So right away, you guys, I would recommend you divide by 10. Before you do any of this crazy multiplication that you feel so strongly about, consider looking at what I'm doing. Can I reduce again?
Yeah.
Yeah.
25 and 15.
No. How about right here? 3. So this is 5/8, right? Now set that equal to 225 over D.
Still divided.
Well, I haven't even started cross multiplying. My point is, if you take some time to slow down and think about the smart way to do the problem, you'll actually save time by doing this little extra step here. Because I've reduced down. So I'm going to cross multiply, and I get 5D is equal to 8 times 225. And I am not going to do any big multiplication, because I can see ahead that 5 goes into 225. Does that make sense? So D equals, 5 goes into there, practice short division. 5 goes into 22 how many times?
20 times. No.
4, but it's 4 times 5 is 20, so the remainder is 2, right? And then, yeah, 5 goes into 25 5 times. So now I have 45 times 8, right? You see that?
Yeah, 350.
See, right? Yeah, because 8 times 40 is 320, and 8 times 5 is 40. So 360. And then the units are what?
No, meters.
They were meters?
Yeah.
Okay. Raise your hand if this helps a little bit. Okay? I think we're going to stop there. I have the worksheet for you.